But I think I have a Steve volunteer who is, oh, damn, okay.
The heads all go down.
He didn't have time because he probably didn't hear properly. Are they talking about 10%? Oh, yes, they are talking. Oh, damn. And I have that.
It's the 28th or the 29th.
28. For my clock. My clock. Yeah, it's different.
We probably just need one. We should probably sign it though.
Much better if you actually go to the other side with the space there. You can see your, you know, and we can see you, which means that you are personally anyway.
Should just turn the projector off on that.
Yeah. I mean, we have enough space. That's this side. We don't have to use that side. So should we actually go and edit that? We are not in the column 1 and 2. We are only 2. Or actually, it's 5. All right.
Yeah, this is the worst room possible.
It's okay. All right, so I think it's time to start. So I'm Tero Kivinen, and this is IPSECME working group meeting. And we have a quite tight schedule, so we will probably go forward very quickly. The blue sheet should be, sorry, this is a note well. You probably have seen this at least once before this. So we have blue sheets going around, and we would like to have a couple of note takers. We are using the Etherpad to take notes. So if you are, you know, in the mic at the middle or something like that, that doesn't matter because maybe other people can help you. And I already pre-filled the Etherpad with you know, all the agenda items. You just need to fill in what we decided. So, any volunteers?
We'll happily wait until we have 2.
And then we start removing, you know, from the agenda item. All right, Jabber, that's fine. Any notes takers? Joab?
Okay, if there's nothing reloaded.
There should be. Did you take the link that is actually in there here?
Oh, you know what? This is the wrong link.
That was the link I used to fill it up.
It's scratch.tools from the link. It changed actually since the last meeting.
Oh, but I actually filled in the tools version.
Yeah, just copy that over to the other one.
Okay, so let's see.
And supposedly they made this it's the same server, and they were supposed to make it so that it would work either way.
And I was very fast typing in all the stuff. All right. So is there anybody who would like to help? You know, Justin Bergis, when he is going to be on the mic, because he usually is. All right, Paul will help out. All right, so we have Chopper, we have a Meet Echo, we have an Etherpad that has the wrong URL, and we have here is our agenda, and it is. We are still have 2 minutes before we are to go here, but we are going to be. We have lots of 10-minute sessions, which are, you know, going to be hard to keep in time because people are always want to have a discussion and not very time for you know, questions. All right, so let's go to the working group status. So we have one, you know, draft that is finally in the RFC editor queue, the split DNS, and actually one thing I forgot from here, but that the EDDSA is actually now published as an RFC. It was in the RFC editor queue last time, I think. And then we have already requested the publication for Impact IV, and we have, I think we have a very long working group last call done with, you know, QR Ike version 2.
Actually, the only thing stopping it from moving forward is there's a small number of nits on the draft. So the write-up is done, and as soon as I can say that there are no nits, it will go forward.
All right, and then we are now working on this IPv6 and IPv4 codes, and then we have a couple of other items there, but it's like the working group draft that we are working on. So let's start with this last one, because the person who is the author isn't here. Oh, you have a question?
Just a comment about quantum resistant. There are a couple of needs, but one need is false positive, and third track was considered, it's the payload type, it was considered as a reference. And the other need is a reference of old version of Paul Hoffman draft. Anyway, I can fix it just in a couple of hours, just a minute.
That's fine. And just email me about the false positive.
Okay.
Thanks.
All right, so this is the IPv6, IPv4 codes, and we have been having discussion. Actually, it might be so. The person the author isn't here. He's at the other meeting. We have giving presentation share, so it's my job to give this, summary, and it's a little bit unfortunate because I'm the other side of this discussion. So this is what he has been proposing. And the question here is how to do IPv4 and IPv, address assignment when you have some kind of policy. You only have, for example, if you haven't, here is the first line. It's an IPv4 requested, and the respondent only supported IPv6. It can, of course, can't allocate any addresses. It just says return error code of IPv6 only allowed, and so on. And same thing if he, if you request an IPv6 and it supports IPv6, it gives you an IPv6 address and still says you that IPv6 only allowed, meaning that even if you ask IPv4 separately, you wouldn't be getting that. And if you ask, IPv6 and the responder only supports IPv4, it will not assign you anything and gives you only the IPv4 allowed. And same thing with IPv4, only stuff. And then we come a little bit more interesting stuff. If the requester asks both IPv4 and 6, and the responder only supports IPv4, he of course gives you an IPv4 addresses and says IPv4 only allowed. And same for IPv6. And then if you have a policy there saying that, oh yes, the requester asks both IPv4 and IPv6, but the responder supports it so that you can have either one of them, but not at the same time. So he returns, one of them, and he doesn't return any error code because it's, it's not only IPv4 or IPv6 supported. And the last one is that we support both IPv6 and IPv4 in both ends, and we returns both of them and no error codes. I didn't like this proposal because there was two notification codes, and we already have these cases in some other places where we have this kind of additional XXX, allow or possible. Like we have in traffic selectors, we have additional traffic selectors possible or something like that. If you try asking something and you get something back, but that's not everything. You could get more if you ask more questions. So in here, if you ask IPv4 and responder only support, IPv6, it doesn't return you anything because it can't fulfill. But it says that if you ask, something else like an IPv6 address, you will get that. And if you ask IPv6 address and you get IPv6 address, that's what you only get. No error codes. And same thing if you ask IPv6 and responder supports IPv4, it doesn't give you anything but returns an error code. And these next three ones it just does what you ask, without any error code because there's only one option. The second last one is the interesting one. Is if you ask IPv6 and IPv4 both, and responder has a policy that I can do IPv6 and I can do IPv4, but I can't do them on the same essay. So it returns you either IPv4 or IPv6, and it tells you that by the way, you could have more if you just make a new request with for example, only IPv6 address or something like that. So the question now is, what is the group's, feeling about that? It's mostly same. I think the one that is, additional thing is something that we have used earlier. The other one is it's a bit more explicit, saying that only this one is supported, only that is supported. the original version, they had, a couple of more extra codes that we got eliminated. But do you have anybody have any comments? Nobody has any feelings of how to do this?
Valery Smyslov for this plus. I think it was discussed on the list and alternative designs. Well, it was you who suggested it. It was me who suggested it. Well, anyway, the main idea is first not to use error status type notification, instead use error notification, instead use status type notification, because it's well, they ignore it if you don't understand it. It's okay. And don't say only it is supported. You support IPv4, you support IPv6, and minimize the number of these notifications. So I think the terrorist design is good, and my design was, I think, good enough. It was very similar. So the draft, I think the draft needs to be changed to accommodate these ideas. It's my opinion.
So you would say that this original address stuff type of thing with one error code or one status notification. Actually, all of these are status notification codes would be better in your opinion, right? Any other comments? All right, I think we need to continue this on the list because I don't think we have enough people commenting here, and if we have only one or two people and the outer in the other side, I think it's we don't have a clear consensus. And both of those are actually acceptable. I don't think there's anything wrong with their choice. It just would be more nicer to have less codes and so on. All right, so I think that covers our current drafts that we have presentations on. And then let's go to the work items. So the first one is the, this intermediate exchange. So Valery. Okay.
Just press this.
Yeah, but I did find the first one, this one.
Oh yeah.
Okay.
So hello, this is an update of intermediate exchange. It was previously called OX, now it is called intermediate. So just if you forget, a quick overview, what is it? So if we need to transfer a large amount of data between, not between, but before ICE, we define a new exchange type. It is called intermediate, XICOX. And it is containing encrypted payloads that it can be fragmented, so we don't have any issues with a large payload size and IP fragmentation. And so what was changed from previous version? So some bug shading. The exchange was renamed to intermediate because most people complain that ICOX is not a good name. It can be very, very well mixed with ICAUS. Well, I don't know whether this name is better. Well, I hope, but if somebody has more suggestions, we can continue this by shading. Well, so as a result, on the consideration section updated to reflect these changes in the name. And the other change is more important. It was changed in the way the exchange is authenticated. So it was a discussion with Scott about this particular issue. So in previous design, each party includes only his or her own intermediate exchange messages into its signature. So, and we have some discussion, it is written here, with Scott about this, and he suggested advised to change the authentication scheme so that all messages are included in each party's signature, as it is written here. So I think that it is more safe. I hope, at least, it won't hurt. So I think it's a change that nobody will object to. And besides, couple of minor changes is made so that the order of the inputs to PRF is changed so that it will be more convenient for implementation, because I've implemented it. It is just a result of implementation, just to save one buffer allocation, just to change order for input to PRF. I don't think it's important. So what is impact of new authentication scheme of intermediate exchange? So I think it strengthens authentication, and it makes more convenient for implementation, simplifies implementation, and that's all. So I think the chair has already issued adoption call for this draft, and if you have any comments or questions.
This wall is weird. Okay. Paul Wouters, right. One bike chat and one question. Since this is changing the message ID in the IKE auth, should this document update 7296, which might say that the message ID is number 1 specifically? I don't actually know.
I'm not sure it stays. We can check, but if it is, it's possible to. Well, no. Well, it's a question to our chairs. As far as I remember, Tara's opinion was that if this particular feature is negotiable, you don't need to update the core document.
And actually, if you talk about if the base RFC says that a message ID is incremented for every single, frame. Every time you send the extension,
Sure, if it says that, there's no problem.
and it doesn't. I don't think it actually ever says explicitly that the IKE out is always message ID 1. All the examples, of course, have it 1 because it's a second extension. I don't think it actually says anywhere that. And actually, IKE out can have multiple ones. These have 1, 2, 3, 4,
Right.
depending on
Okay.
the EAP obligation. So I don't think it actually should update, and I don't think actually should affect.
Okay. So the second question was, I would like some clarity on what to do when the IKE intermediate exchange is empty. Throwing an error seems silly, but replying with an empty message also seems silly.
Well, the current draft says that probably it is not very explicit, but it is said that it must be accompanied with another document that describes how to use intermediate exchange.
Yeah, but then you must tell me what to do if that's not the case.
Yes, that this supplemental document must define whether it is okay to have empty exchange, what it must be contained, so it must be application document. So currently, well, actually, from a general point of view, it's okay to send empty intermediate exchange, but it's useless. So there must be some document that defines the content and defines the condition for the using of intermediate exchange.
I just don't want to deal with different implementations sending different notifiers like no proposal chosen or bad format or whatever. I just want to be sure what to expect. And then my last bike chat comment, I really want this to be called IKE_intermediate instead of just intermediate, because this is only relating to the IKE. And if we would have done things the best way from the start, all the IKE related exchanges would have been called IKE_. So I would prefer IKE_intermediate.
I have no objections. It was just a mimic informational that lacks of IKE informational. So that's why we have information and intermediate.
But informational can actually be about IKE or IPSEC essays, just like create child essay can be about both.
Well,
but this is only about IKE.
I don't mind. So if you think it's important, we can change it. Please bring it to the mailing list so that people can express their opinion.
Tommy Polly, Apple. So in general, I think it's good. I like the updates to the document. So I support it in that regard. I agree that having IKE_ in there would be a little clearer. So don't really care too much, but a minor +1. And then just to clarify, because I looked up the text around the only thing that mentions IKE auth being packet 1, it's in the part that we're defining the message IDs, and it says that the init is message 0, and then just has an example sentence in which it says, thus the first pair of IKE auth messages will have 1, then the next thing will have 2, and so on. So I think it's totally fine. Don't worry about it at all.
Okay, thank you.
Hi, Tobias Heider, Gino. I was also wondering about the exchange ID. We do need additional drafts providing extra content for the IKE intermediate. Why don't we allow them to set their exchange ID? So the user can say, this is IKE_ additional key exchange.
So do you want to say that each application protocol must define its own exchange ID? No?
I'm saying that maybe it would be useful for the drafts, like the ones that are actually using the IKE intermediate, providing their own ID.
Oh, I don't think it's, well, I think it's possible, but isn't it duplicates the work, doubles the work that the draft has already done. So I think that content, in any case, you must define a content of intermediate exchange, but the current draft serves a main purpose. It defines how you authenticate this exchange and how it is negotiated and how errors are handled in case they happen. And if you redefine it in every application document, you need either to repeat all this text and probably to repeat the code. I don't know, depending on implementation. So I think I understand it's a framework document. So it's useless without any application document. But as a framework document, I think it's better to have it in one place, all these issues. So.
Tero Kivinen, not as a chair, but yeah, I think it actually is, because if the intermediate exchange is really a framework, so we could say that, okay, we don't have an exchange type for it at all. We only have say that this is the framework, how to do these things. This is, how to negotiate things. This is how you actually send the, stuff. And then all the, documents that actually, use it would then define their own, which would have a good thing, because then we could actually have a, example, like we have if we have an IKE out, we have a create child essay, then we could have, USGA, exchange there, which is using, the framework of what you have there, but using completely different. It would allow, this kind of, and it also, but of course, that would also mean that and actually, I think that's actually one of the things that, negotiating intermediate is actually most of the time pointless. Because you are not really negotiating that you are going to use framework. You want to negotiate that I want to use this feature that is using the framework. Which, of course, if you are going to use USGA, and it requires intermediate, there is no point of saying, oh yeah, by the way, I support this and I also support this, because they always go together.
It might be more complicated. For example, you can use QSKA without IKE intermediate if you perform exactly one quantum safe key exchange and a small public key and make a SINID. So they are somewhat decoupled. That's why it's an additional negotiation of IKE.
And of course, the other the other side of this is that because we are still want to do that, this is exchange we do before IKE out, and it's not a generic this kind of thing. You could say that okay, this has certain meaning because of that it's only meant to be transport stuff that is needed for IKE out or before IKE out. In that case, it could be say that okay, we have that, and then you could have a negotiation of the IKE intermediate, which actually lists what protocols can be inside there. Like it's for because you have the notification of supported, you could have a fields there telling that we do support this key ID more, this key exchange more, this key exchange more, so on. But I mean, both of these are actually valid, and I think it would be useful to think about and see on that. But I don't think, yeah.
I guess that was my point.
Tobias Gogomus from LMU. I think we had this discussion on the list, and I found your point very good, that you could use an application which works without intermediate, but can benefit from intermediate. So you can do PQ,
That's what I was talking about, yes.
In the IKE init if you want, if you don't care about IPF fragmentation. But you can benefit from IKE fragmentation if you want. I think that was the point which I found convincing.
Sure.
No, actually, there was a question that we actually do a hammer on this, and I think actually this is too early. I think this actually isn't anything that we can actually start working on this when we have this as a working group draft. So I think because I mean both of these are actually completely valid ideas, and people have been and I think it's more like a design this kind of what is nicer, and it depends on also how many of these things we have. If you're going to only have your one QSKA is the only one that's going to be using that, it's a little bit different than if people are seeing that we can have several different other things that we'll be using, then it might be a little bit different. But so I think this is actually something we should go to the list and think about there a little bit more. But now I want to actually answer one question does anybody see have any objections to taking this as a working group draft and knowing that we can actually still continue working and modifying it heavily when it's working group draft? Actually, more easily because we can always change its author if we. So, and we have already discussed this in the list, and I haven't seen anything in the list that would say otherwise. So I will actually go and push the button and make it as a working group draft. So you can actually submit the next version with the proper name. So that's go on next. Yes, this one. So many buttons to press.
Hi again. Back to a more controversial topic. It's quantum resistant IETF2 draft. The draft was updated and it perceived quite a lot of changes. And so the first slide is just a review in case you forget what it is all about. So we're all expecting that quantum computer will come soon and break all the security, all the cryptography, public key exchange cryptography. And so that's why a new method that post-quantum secure are to be appear, but all of these methods that we are currently known of have a huge public key, most of them. Well, and more cryptography are not sure, are not trusted, completely trusted to any of these methods. So the idea is to combine several post-quantum key exchanges and to steer their key into IKSA keys computation. So the idea is to use intermediate exchange, and that will contain, that will transport additional post-quantum, probably post-quantum, but anyway, it doesn't limit it to post-quantum, additional key exchange methods. And then this key, the shared key, new shared key will be steered into new key seed that will be updated after each intermediate exchange, so that each subsequent intermediate exchange is protected by a new key. So the security will be incremented. So that's an idea. And what was changed from previous version? There was a very long discussion how the use of additional key exchange should be negotiated in IKE. We came to conclusion, the working group came to conclusion that we are reusing the current negotiation mechanism in IKE. So we are negotiating the SA payload. So I will talk about this later. This is just an overview what was changed. So using multiple key exchange create LSA is defined so that post-quantum key exchange method can be used in a key in IKSA or in creating child essays. So the name was changed to intermediate to reflect with the new name of intermediate draft. And a consideration is added that was absent in previous draft. And some stuff was deleted that wasn't really, we decided that it is not relative to, not very important in the draft. So negotiation. So for negotiation, we use the following scheme. We define a new exchange types. So each new 7 new exchange types, which are essentially the same, just number. And each new exchange type will define which key, well, all of them share the same registry for transform time 4. So all new key exchange, post-quantum or classic, will have the same registry, and all of them will be available for this additional key exchange type. So the number of key exchange type will define the order of these numbers, will define which order the key exchange will be done in intermediate exchanges. Question?
Yeah, or I say more a comment. I would hate to see that kind of things happening. I mean, having 7 new traffic types is bad. All of them sharing the same transform type 4. is even worse. And because they are not interchangeable. I mean the Diffie-Hellman groups we have in transform type 4 are groups for specific Diffie-Hellman type of thing. These are complete key exchange, things that don't have anything to do with that kind of thing. They are resulting in the same thing, but they don't have the same kind of, mechanisms. And I assume that they also will probably have some parameters inside. Might have.
But
Yeah. So I would really think that if we actually want to make a new transport type, we would actually make a new one and make a completely new register for that would only include the things that are in this. And I don't really see that we actually need to have it and the order. If you actually want to have an order negotiated, that's also something that is in most of the cases it's very fixed.
No.
It isn't, because usually the policy has to say that we do this and this and that those are the only ones you trust, or it might be saying that we skip things that we don't support or the other one doesn't support, but usually it says, okay, for example, if you think about the multiple authentications, we have this draft that does multiple authentications. In that case, we already left everything in the, we don't actually negotiate what authentications we are doing in the beginning. We just do different authentications and, and I assume that they are configured in the both ends, or actually the recipient will ask for something, or actually I don't remember this way. But anyway, it's one by one. You do one, and then you do other one, then do other one until the other one is happy with saying that okay, now I'm done. And I think similar kind of thing would be working here.
I don't think it's similar. I think it's different. Well, first, let me answer. Let me try to explain why this design was taken. First of all, from protocol point of view, all these post-quantum key exchange serve the same purpose as Diffie-Hellman. So it's key exchange methods. Then sharing a single registry will allow us to use this post-quantum key exchange in IKSA need to. So you can just put it in transform time 4, and you will, if public key is small enough. So it's very convenient in the future. Then it will allow us to use classic key, multiple classic key exchange. Some people like it. So I think that it was discussed among the authors. It was discussed quite a lot, and it was quite decisions that was discussed, and everybody agrees that it is better. So.
Valerie actually talked about most of what I was going to say, but I'd like to emphasize that one of the things we specifically wanted to do is allow, well, we'll do this particular classical group plus either this particular latest group or that particular latest key exchange, and also we'll insist on a misogyny group. This sort of construct allows that to be done relatively straightforward.
Tobias Heider. Well, first of all, I also see good reasons to use two classical key exchanges that we have right now combined in a hybrid key exchange. And Tero, I like the idea of just adding another layer of hierarchy where you can sort them into groups. But I would still put the old ones in there as Diffie-Hellman groups. So you could still combine old ones the way you like it. And you actually need to be able to decide which is first, because the first one has to be the smallest one because it's in the IKSA init.
Yeah.
I had some of the same comments about the transfer types, but Mark McFadden. But maybe I would just ask a question because I'm just confused by something. Is that in the registrations that you make in the IANA consideration section, you have 7 of these, 7 new ones, right? Mm-hmm. But I don't see a place otherwise in the document where it talks about that limit, that the number 7.
Well, it's an arbitrary limit. Well, we discussed it among the authors. So it is the limit of the maximum number of additional key exchanges that can be handled in IQ2. So we decided that 7 additional key exchanges is quite enough. But probably, well, if somebody thinks that it is not enough, we can allocate, I don't know, 16.
Sure. I mean, and so I think 7 is as a random number is as sensible a number as any, but maybe that argues for the hierarchical idea that another speaker suggested, and that you wouldn't have to determine a fixed number.
Well, the motivation for that was that, again, Scott's idea was that in most cases, the post-quantum key exchange of completely different types will be combined. So currently we have isogeny, Cody-based, lattice, I don't know, and 3 types. Let's double it in case the few will appear in future. So that's why the number 7 is appear. But anyway, we can, if it is insufficient, we can allocate more.
I don't think I mean, we could do this also so that I don't see any reason why we have to negotiate all of this in the first essay payload. Because if we negotiate in the first essay payload, that's going to be very difficult to have if we have any parameters still. You know, what is has this invalid key A group or something like that, how that interacts with there, and so on. You know, how do so what I was thinking about, it would be better to do that we actually, each of these intermediate steps has negotiated, okay, I want to use one of these 4 key exchange methods. One of them can be classical group 4. The other one could be, group, the type 4. The other one could be, type 7, which is, or whatever the number is, X number, which is saying that we are doing this kind of, post-quantum, algorithms. And then the other one, when it receives that, it picks whatever it thinks like it's okay, or actually, if the problem there is that if the key exchange, payloads are big, you probably want to, guess correctly, or you want to actually, negotiate it first and then do the extra round trip there to do the negotiation. But having them to be, negotiate in the beginning all the 7 different algorithms in the order what they are going to be doing is going to make an SA payload huge if you want to support multiple different combinations of those, because you have to say, okay, you can do this first, this first, this second. Okay, of course. I also want to make that you are not going to be selecting all 7s to be 1000-bit Diffie-Hellman to group 4, but you would propose that in all possible places, because you would say that you can do that one in any place. But doing that 7 times in a row is actually not going to help anybody. So that's why I was thinking about doing this in the beginning is a little bit bad. So I was thinking about it would be better that way, that we actually in the first IETF essay. I can say in it, we actually negotiate the first, key exchange and the next one, 2 first. The second one, we already has responded. The other one, the responder has already said, okay, let's do key exchange 7 or XXX next. And in the next one, you do the key exchange payload XXX, and you propose what would be done after that. And one of those options would be no more, I'm happy now.
Well, what I'm proposing will complicate the protocol first. Then I think that having ability to negotiate everything in first place will actually a good thing, because after IKSA need is completed, each party knows what will follow. In your proposal, for responder,
but
have
you tried creating how big essay list that you have if you actually propose 7 different in random order and in a way that you can't actually select same key exchange method for every piece?
I don't think it's a problem. Well, and for about the essay proposal size, we have a draft for compact representation of essay payloads, by the way.
Mark Ojanowski, NCSC. I wanted to say that I agree with the principle of not giving any special treatment to the quantum safe groups. I think they should be in the same registry as the Diffie-Hellman groups, because I want the flexibility to be able to take a classical hybrid or a quantum hybrid if necessary. Having them all in the one place helps to achieve that aim.
Okay, thanks.
It's Scott Fleur. I'd like to respond for about Patero about 2 things. One about parameters. Well, I would like to remind them that transforms can have attributes, and it's unclear at all. It's immediately unclear whether or not it would make sense to have attributes to key exchange transforms, but the possibility is there. In addition, he seems he's worried about the size of the essay proposal. If you have if it's rather complex, I believe that with the inherent and/or logic, which is built into IETF2 proposals, I believe the length would be actually reasonable for most reasonable policies.
I think we are running out of time, so we have to take this to the list.
Well, so back to negotiation. I think it's already discussed. Well, actually, it just explains how negotiation is done, but it is basically done as an usual IETF2. So the only difference is that transform type currently in this proposal, these additional transform types don't define a new cryptographic primitive. They define a key exchange primitive and the number of the order of this transform type, not the order but the number, defines in which order this additional key exchange must be performed. That's the only difference. So, well, 2 more points. So initiator may include non-transform ID if in any of these additional key exchange. And that means that these, the key exchange that are proposed with the same number are all optional. You may select none and it doesn't do it. And for compatibility with legacy implementation, you need to include two payloads, two proposals, one with additional key exchange time and the other without. So, well, it's just the properties. You can perform quantum safe key exchange like I say need. That's a good thing. That's a property. So we share the same registry. And so this is an example of how a safe payload would look if you express your policy of I want to do ECP 5 to 1 in IKSA needs, then New Hope, then further, then either RLV or LV, or then either Sitcon and or nothing. It's just an example. Well, another stuff, and using additional key exchange and create LDC. It's not an easy task. And we've discussed quite a lot about it. And the current proposal is to, the requirement that we're taking into consideration is that message size of create child design might not be too large. In any way, it must not differ very much content, in very much differ from the initial, from the size of initial IKSA establishment. So that's why the idea is to not to put all key exchange payload into single create child the same message, but instead have a trailer information exchanges that mimic IK intermediate exchange that are used that were used when IKSA was initially created. That looks a bit unusual, probably a bit complex, but anyway, we think that it has there are some advantages of doing it. Well, question?
Yeah, you have here. So if you want to map this to the stuff we do in regular IETF2, this is in case that we're doing the child essay with perfect forward secrecy.
Yeah,
we still have the option of creating the child essay without perfect forward secrecy.
This is IK keys always.
All
IK key always has a perfect.
Or key in child essay with PFS. So 3 cases. And so this is a scheme how it is implemented. So we have create child essay, and if peers agree that several key exchanges must be performed, then this create child essay is accompanied by some trailer information exchanges that perform additional key exchanges. And only once all these exchanges are done, the new essay is created. So there is a new notification, additional key exchange that allows responder to link it's easy for initiator to link these exchanges because he sends a request, receives a response, immediately start new request. So it's the single state. For responder, it is a bit tricky because once the create child essay is over, it must save state somewhere, but he must link it with one of the next information exchange. In case the window is greater than 1, they may be interleaved. So that's why the new notification is needed. So it is like cookie. So it is meaningful only for responder. It allows him to link this exchange together. So next steps. So just add more clarification. A lot of clarification is needed. And yesterday we had a side meeting discussing quite a lot of stuff, in particular about create child essay. And I think that Tobias sent a message to the list. So I think he just summarized everything we discussed there. So the draft needs to be worked further. I think it is evolving. So any questions, comments, way forward? Well, we are looking for adoption of this draft. So I don't think whether it is premature or not, but actually it's our goal.
I support adoption of this draft. Yeah, we've got a requirement for it. I'd like to see it progress as quickly as possible.
Okay.
To be decided, I also support adoption, but I would change it to be about hybrid key exchange, not hybrid post-quantum key exchange, because it can also do the classical one, and then do the post-quantum stuff in another document.
Okay.
Because there's no transformers IDs in there
Well,
anyway.
well, as far as I understand, the draft must describe how to use key exchange with payloads, with public key of large size, without mentioning post-quantum, not post-quantum, so that's...
I mean, there's a motivation to do that, so
Okay.
you can mention it.
Well, we need to be mentioned, because otherwise what is it all about?
Yeah.
So in the IETF, we generally are adopting an approach, not a specific draft. So I would prefer that we work out some of the mechanism issues here before we adopt the draft properly. So maybe we can resolve the mechanism discussion on the list and then do a quick adoption call then.
Just as a matter of processing, there's no point in adopting intermediate if we're not adopting this, and we can't adopt this if we're not also adopting intermediate.
I agree on that. Yes, I think we should probably adopt this, and we can modify it even if it's a working group document. It's no problem. But we are running out of time, so I would actually, if you have a very short comments, you can do it, make it. But
so very short. I think it's better to adopt and do the change than being in a state where we don't really know if the engagement and the energy to spend need worth or. So I'm in favor of the adoption.
So, thank you.
So we would ask that all presenters be as brief as they can, because I think we're currently 10 minutes behind schedule.
So we'll hurry up then. I'm Tobias Heider. That's an implementer's view in the hybrid post-quantum key exchange, and I'm the implementer. So that's what all the fuss is about. Those are the 17 key exchange candidates that are in NIST competition right now for post-quantum key exchanges. We see there's 3 big categories: lattices, codes, isogenies, and all of them are they do have disadvantages compared to what we're using now. So they do have bigger keys, they might be a lot less fast, and we don't know how secure they are overall. So we actually want to do a hybrid key exchange because we don't really trust them. So we want to have a fallback, which is our classical key exchange. So what we do is we combine a classical key exchange and one of those new methods. And that is, here's a simple method of doing that. Like the most simple method you could do, just define a new group, call it streamlined n2 prime plus x25519, concatenate the keys and put them in the KE payload. You can just use that group as you use every other group. And now you've got a post-quantum key exchange that is also hybrid. So, well, that wasn't even hard. Downside, the solution is limited. So you have to predefine your groups. There's fixed combinations. that's a problem, might be a problem. And also you can't use fragmentation. So talking about fragmentation using the 1280 IPv6 fragmentation threshold, that's what you still can use if you cannot fragment. And it's even worse for IPv4. So there's only 2 things left that you could use. So that is not just the right solution to that problem, actually. So my next implementation is based on Valerie's draft, or what Valerie just presented. So what do? You just add an additional intermediate exchange that exchanges another key. So ICASA init is basically the same, just the SA also includes the post-quantum key exchange negotiation. And then you do another round and basically do the same as if you rekey. It looks great. So it is the same as before, just using new approach. Now, there's also challenges. That's the rekey, and it looks complicated, and it is complicated, and it has a lot of problems. We have to keep state. We have this additional notify using that link cookie, because actually the transmission window might be bigger than 1 in that case. It cannot be in the initial key exchange, and that was a pain to implement, actually. So I would actually, the only reason we've been using the intermediate and not put it all into the init is because we cannot fragment the init. So we can fragment the create child assay. we can just put it all in there. So we would do an educated guess on what the responder's probably accepting, because we don't know yet. But I think that's not a problem. Just put it all in there, and he's gonna accept it or not. Otherwise, it's just handled the usual way using invalid KE payload. So now, finally, we've got it. We can do fragmentation. It's a fully functional hybrid key exchange. We can do post-quantum if those methods are actually secure, right? Not yet. There's 2 more that we do not support yet. And why don't we support them? So I made a plot. On the y-axis, we've got the public key size in megabyte. On the x-axis is the encryption speed of these mechanisms. And that red line down there, that's the 64 kilobyte, which is the size limitation of payload substructures, actually, because payload's got a 16-bit size field. We can put those in a KE payload. And McAleese is actually quite special because it's quite popular among the cryptographers, because it's been around for several years, like 1978, I guess, and it hasn't been broken, and it has gotten review. So if you want to do post-quantum key exchange today, you probably would want to use that one. And that's an unresolved problem. We've talked about it yesterday, actually, but there's no documented solution to it. So, conclusion, I would like this draft to reduce the complexity overall, especially the rekeying. We should find a way to support McAleese keys. And this draft does not contain any post-quantum key exchange transforms, so either put them in there or relabel it to hybrid key exchange, because that's what it is right now. Otherwise, it is functional. We can do hybrid post-quantum key exchange, and I guess there's no security problems there. So, Valerie.
Valerie Smyslov for this plus. I want to say that I've also implemented this draft. So there are 2 of us at least. And I think that create child assay is, well, a little bit challenging to implement, but otherwise the proposal to put all the key exchange below into the same message has significant drawbacks, so that message would become extremely large, quite extremely large. And we don't want the protocol to lose reliability because of the great number of fragments. That's why this design was selected. And well, I think that it's a bit challenging, but actually it is not. It's doable, and I've implemented it, so it's not a big problem. And the other comment I would add, it's about the McAleese and the same. So we've discussed it yesterday, and actually the idea was throwing before there's a mailing list, it is quite possible. If people do want to use these keys, so we can do it. Well, it is not in suboptimal way. We can break these huge public keys into several key exchange payload, adjacent key exchange payload, and just put them into a single message. It is not a good, it is not optimal way, but it is workable at least. So just if people do want it.
Thanks, Valerie. So yeah, actually, I made these slides before I talked to you yesterday. So I do know your position on this, and I see now the problems you try to solve. I still think this is not the optimal solution. So maybe put it all into a single other additional key exchange. Don't use informational. So I don't like the use of informational. You would have to, you know, parse context sensitive and see where you are, and if this information actually contains the key shares and so on. And maybe put it all into one additional, I don't know, I cannot offer a solution, but I see a problem there.
I'm cutting the line after Yoa.
Okay. And Macalis, we can totally do that in another document, right? I would just like to say that it is important. I guess there's people here who would like to have support for Macalis, right? And it would be nice to find a way to integrate it.
I don't think it's going to be too difficult to define, I don't know, an extended size payload that has a 4-byte length field. I mean, well, yeah, Tara doesn't like it, but, I mean, yeah, you probably wouldn't want that in regular UDP. You'd probably want it only in TCP or maybe some future quick-based transport for IKE. But yeah, I don't think it's a deal breaker to have a larger payload than we had originally intended payloads to be.
Yeah, actually, the IKE header does have 32-bit size field, right. So it's only the payloads actually. So
yeah, good. So we can go to 4 gigabytes of
awesome,
key
right?
exchange.
We need to cut the line. Sorry. Can we take this to the list?
Okay, thanks.
Next one.
So hi, I'm Leonie Bruckert, and I will say a few words about post-quantum cryptography for IKE and Strongswan.
Probably closer to the mic.
Okay, so yeah, I'm Leonie Bruckert, and I will say a few words about hybrid IKE and Strongswan. So I think we are all aware that highly sensitive data needs to be protected with post-quantum cryptography very soon. And however, considerable time is required for standardizing algorithms, implementing and testing and so on. So that's why we'd like to have a standard soon. And we explicitly support adoption of these two documents. And actually, we have plans to demonstrate hybrid IKE based on the intermediate exchange. And our hybrid IKE is a bit different from the one proposed in the draft. And when I say our hybrid IKE, I'm referring to the Strongswan implementation by Andreas Steffen and Tobias Brunner. And it's based on an earlier version of the ORGS draft, but I think will be updated soon. And some details. So this implementation supports only one additional post-quantum key exchange, and a new transform type is added called QSQA mechanism. And so negotiation is done via the SA payload as usual. And we also add a new QSQA payload. And the key shares can be transported via the ORGS or intermediate exchange, but they can also be transported in create child SA to allow for rekeying and multiple child SAs. And in case a key share is sent, which is not supported by the responder, we use an invalid QSQA payload to indicate support for another post-quantum algorithm. And for post-quantum algorithms, currently libOQS library is used, which provides some of the round one candidates of the NIST standardization process. And yeah, if you like to have a look on the test scenarios, you can click on that link. And yeah, that's it.
Any questions?
Tobias Gugumus from LMU. I just have one comment, not to the presentation, but in general. Now we have like 4 implementations. Maybe we could do a hackathon.
That would be a good idea.
That would need to have a champion to organize that in the next. Are you volunteering? Good.
Yes, if you pay to Montreal to fly me to Montreal, I'm in.
Remote participants?
But we probably should have some discussion on the list maybe about organizing something. Thank you.
Okay, hello. So Tobias here. I'm not talking about post-quantum, I'm for sure. So we have done with this topic. This presentation is about the ESP header compression, and the presentation is because last IETF we had this discussion, why is this document so complicated? And I would like to explain why it is like that, and I'm trying to make it short. Can anyone here imagine a use case for IPsec in IoT? Or maybe the better question, can anyone imagine there is not a use case for it? Okay, good. So I keep this short. I just run through a few ideas, and you can use it for basically anything you do with IoT. And the basic thing about IoT is they want an IP stack, and our thing is if we want to have an IP stack, then we should allow people to use IPsec in IoT. That's my basic comment about that. And there are many use cases. For example, my favorite one is multicast because it's naturally for IPsec, but that's just a personal thing. IPsec has a lot of advantages for IoT, and one basic thing is that we have a flexibility of key exchange. So we can use minimal IPv2 is already there. It works very well. We have group IC, where we also have a minimal implementation, which works very well for IoT scenarios. We have HIP. I'm not sure if everybody knows that, but it's standardized for IEEE 802.15.4, which is a major wireless protocol for IoT. And we can do one thing. We can just compile and flash the SAs on the device. Why is this an advantage? And why is IPsec not widely deployed? So there are many reasons, but I want to go to one, which is the one the draft addresses. It's about compression. And the problem is the packet size in this kind of scenarios and wireless networks is a problem. Not only because of energy, but it's the major issue. And the problem is you would like to send your data, if you can, in one single radio frame. And I put a few payloads here, which are typical for IoT scenarios. So 802.15.4 is basically the upper line. There are stuff like LoRa, which I got told this week that we can actually go as low as 12 bytes for a payload. Bluetooth can also be quite minimal. So whenever you have an IP stack on that, you want to minimize it. And there are many ideas on how to do that. The one famous solution is a stateless solution, which is called 6LoWPAN. It compresses the information within the packet. So basically the red thing here is the IP UDP header. And with this, it's actually 3 bytes. You can transport all the information you have in this huge IPv6 UDP header. You can do it like that. There is no information left. It's only the payload. Another idea, which is older and younger, is a stateful compression, so that you actually have a compression state between the two peers which are communicating. The older one is robust header compression, where you have a separate channel to agree on a compression context. The newer idea is, and that's the one which comes from IoT, is that you have a static context. So you just compile a context or you flash a context on a certain device. And how this basically works is you have like rules and functions with the context. So you can, for example, say rule 1 means delete the UDP destination port if it's equal to 80. That's what the sender does. And you just send the rule ID 1 with the packet, and the receiver, sorry, the receiver knows, hey, this is rule 1. I know it's UDP port 80. I can decompress it. And you can do that for the whole packet. So, problem with IPsec. This compression usually takes place between layer 2 and 3. So after the IP stack. Problem with ESP is everything we can compress is already encrypted. And I mean, you can compress encrypted payload, but then you maybe don't want to encrypt it. So the only thing you can do, and which is actually kind of done already, you can compress the ESP header, because this is the information which is in plain text there, nothing else. The good news with ESP header compression, we already have this kind of channel to agree on a state, which is our IETF2, group IETF2, we can do it static. We even have a static state, which is our security association. And this state already includes some information we can use for compression. So basically the traffic selectors, if you do them uniquely, you have the IP addresses there, you have ports there, and much more. And actually, we've done this before. Rock over IPsec is already there. The problem is we need to define how to make use of this context. And one thing which turned out like the last, I think, 2 or 3 years, especially in this LoPan community, which are developing this static context header compression, that Rock is too hard, 6LoWPAN is too hard, so we need to do something different. And the problem is this requires specification. So we need to define what to do with every single header of the protocols we want to compress. And this is unfortunately why this draft is kind of long. But I will try to go quickly through what our idea is. It's very close to what the people in the in the LP1 working group do, and they actually like the idea quite a lot. So we kind of split the ESP stack in 4 layers. So we have a pre-ESP, so basically the input of the ESP stack, where you could compress the IP, UDP, TCP, whatever you have in plain text for the payload. Then we have a clear text ESP, so once you have the ESP packet built, then you can compress, for example, the ESP trailer. We have the encryption phase. This is not part of this draft. This is, for example, done by implicit IV, that you can just kind of compress the information you need for encryption. And you can do something after the ESP is properly processed. You can compress the ESP header, or which is also not part of the draft, so don't worry, you could do something with the ICV. But it could be that there is some sort of shorter ICV calculation for IoT scenarios. So the way we do it, and I said it's very close to what the people in the LP1 working group do. We define functions, and the functions basically just says what happens on the compression side and on the decompression side. So for example, send value just means don't compress anything, which is if there are like variable options in IPv4 or TCP or whatever. Deleted means there is a context available which allows you to just delete this specific field. So for example, I have an IP address in the traffic selector, just delete it and decompress it on the receiver. Then we can do something like for sequence number, like basically the reverse idea of extended sequence number mechanism. We can compute values from lower layers. So for example, you can calculate the UDP length from the outer IP length. Checksum is easy, and yeah, padding is something you can also do. That's just the functions you use for compression. And what you then do, you define a rule, what happens on a specific field of the header. So I go back to the example before, for example, the IP address. We have a rule which says compress IPv6 source. The field it affects is the source address of the IPv6 header. The action is deleted, so it's removed. And the parameter, so the value you use, is the IP6 address, which is to be negotiated during the peers. And we defined rules for all headers within ESP we could imagine. And that's why this document is so long. So currently we use ESP, IPv6, IPv4, UDP, UDP-like, TCP. There was even like during the LP1 session, there were people saying we should add CoAP, which is the Constant Application Protocol. So that's basically how it works.
1 minute. 1 minute.
Okay. And then we have the context, which basically just says which values are there. And that's also something which has to be defined in the document and how to make use of it. Again, the example are the IP addresses. The problem remains we have so many header fields which can be part of the ESP payload. I calculated them, like even if you say layer 4 port is one field, so which can be used for TCP, UDP, UDP-Lite. You come up with 44 header fields. You need to agree on the context beforehand. And that's actually much more difficult than it has to be because so many stuff is already there. And that's why we have this strategy kind of thing, which just defines how to make use of the existing IPsec security associations to pre-fill this compression context. And so we have one strategy at the moment, which we call the IDSP. It's mainly for IoT, but it can be used for something else. And it basically means you have to exchange 9 fields during the negotiation, so either IKE or whatever. And it builds you the whole context of all these protocols you could imagine to compress. So you actually exchange just a little information and you can compress a lot. And yeah, that's basically my presentation. I hope it's a bit more clear what we actually want to do there. We have this on the charter on IPsec. The SCHC people are very in favor of it. So I guess we're pretty fine. And I thank you for this idea of this like nice picture because you had this before. And I think we're ready to adopt it.
All right, so I think we are running out of time, so let's move the discussion about this in the list. Next presentation is Paul. And you have to talk very fast.
I always talk fast. Okay, so history, so I'll just assume that people sort of know the history of labeled IPsec. So I'll skip that. This is an example. This is the SPD selector in the kernel. You see that there's additional labels to select whether or not the packet should be encrypted or not. So the original proposal we did was we added a traffic selector with a security label. We added it to the traffic selector list, and people could just pick it if they wanted it. And the main objection there was that there was a little unclear in the main draft that talks about traffic selector picking, because there's only basically 2 types, the V4 and the V6 one, and you would always have to pick one of those types. It would always be clear that you would pick one of them. But then when we start adding new traffic selector types, it becomes unclear whether you have to pick a V4 and V6 one and other ones, or how you would combine them. So after some pressure of the honorable chair, it was decided to basically copy the existing traffic selector type, add a new field to it, and now you can select whether you would which one you would want to send. And so I sort of reluctantly agreed to this idea, and then up until about 2 weeks ago or a week ago, we were at the Linux IPsec gathering here in Prague, and somebody came up and said, "Oh, by the way, I have some new SPD selectors I might want to support in the future." And they came up with VLAN XID and other things. And then I started thinking, well, we cannot do this solution because now we're going to get a combinatory explosion of all the things that people might not want to do. So that basically brought me to the problem of like, is this really the way forward? I think actually it might be better that we clarify you must pick a V4 or V6 original traffic selector, and of all the other traffic selectors types that are sent, you must pick one of them. So if there's any sec label, like separate sec label traffic selector type sent, you must pick one of the sec label ones, and otherwise reject the proposal or pick another one. And I think that is what I said.
Okay. And I think your draft was already as a working group draft, so we should discuss this again at least. And yeah, I think that if you have more of those, I agree on this. But let's see. All right, your next presentation. there might be some discussion about this.
Okay, IETF1, great. This got triggered by the I2 NSF working group that did some drafts on putting some of the IPSEC modeling into their Yang models. And then we suddenly started seeing all these obsoleted old things that they put in, because they're, unfortunately, as you might have heard me say on the plenary, they're trying to put IANA registries snapshots into RFC documents, which is kind of terrible. And suddenly I see these options like, oh, we're going to support one DES, and actually it's not even the ones that we've already said not to use. It's like CAST and IDEA and all these sort of algorithms that we haven't deprecated because they weren't weak, or we didn't find any attack for them, but we kind of lingered them in from IETF1 era times. And so what we really needed, apart from the regular algorithm cycle update where we give implementation recommendations, we should do something with all of these collected May entries that we have left, and sort of write one document to put all of them together and say, don't use these anymore. And that's basically what this draft did.
Tero Kivinen, we are not in the process of giving instruction to people what to use. We can say that, yes, IC version 1 is already deprecated, but we are not supposed to say that they don't use this. It's not something that we should be doing.
Okay, well,
we can say don't implement it. That we can, because we are giving instructions to implementers, not to the users.
Sure, fair enough. So whatever I said recently, just SCD, use, implement.
Dan Harkins. Yeah, this kind of reminds me of H.L. Mencken's comment about Puritanism, where he said that it's a haunting fear that someone somewhere might be having fun. And this seems to be like a haunting fear that someone somewhere might be doing IETF1. And, you know, I'm not sure really why we care. Regarding using IANA as a way to kill off a deprecated protocol, I don't think that's really the point of IANA registries. I do agree that things like Tiger and CAST we might want to deprecate.
Yeah,
but
I think the deprecation is only for the it's only for a cipher strike.
Yeah.
No, the draft actually says to deprecate the entire IETF1 registry, which I think would be a mistake because people.
We can't do that anyway.
That's what I'm saying.
Because the registry,
other people are using that registry, and we can't. We can't just go deprecate everything that has to do with IETF1.
So maybe deprecate wasn't the right word, but so there's this informal agreement in the room that we will not add anything to IETF1, and I was trying to more formalize that in an RFC, saying that we will not do that anymore.
Well, it's already obsoleted. I mean, and the updates to the IANA registry that we've done since IETF1 got obsoleted actually says in the notes, not for use with ROC 2409. So I'm not sure what else. I'm not sure why anything else is needed.
Okay. So you mean nothing is needed with respect to IETF1, only with respect to some of these lingering May algorithms?
Yeah, I mean, I think the IETF2 updates are probably a good idea to get rid of CAST and, you know, triple DES and all that other.
Well, so for that we have the regular cycle of updated algorithm requirements, right? Okay. So these are more of like the sort of things that we all implicitly didn't do anymore, but we didn't sort of tell anyone not to do them anymore.
Okay, it just I read in your draft, it just says, you know, IANA instructions to tell IANA to deprecate the entire IETF1 registry, and it's
okay.
Like,
So that was maybe a little
okay,
a little too much. Okay,
so we're going to cut the line.
Valery Smyslov, LS Plus. 2 points. First of all, I support the idea to, more deprecate IETF1. We already removed it from our product just last year. It is not implemented, what Tero wanted. And the other point is please save AH for now. It's probably useless, but at least it is harmless in comparison with IETF1. So please keep AH for now, just for the reason, because it provides some capabilities. Probably nobody use it, but at least it is harmless.
Well, but that's exactly what we have now. Like we've got all these entries
that
we think that are harmless, but that are not being actively used. So how reliable is it, and how robust is it if you actually end up using it?
Please make these comments short.
Okay, sir. Thank you. Okay, Benedict Wong. I just wanted to make a comment that we can't really get rid of triple S. As far as I know, it's still using telephony, so that one still kind of has to stay.
Triple S is actually in our regular cycle of algorithm recommendations to be slowly migrated away of and not just like killed one off. But we're really talking about things we forgot, like CAS. Like there was no reason to say don't use CAS, it's insecure, but because it's not. But then again, nobody has researched this for 20 years either. So do we really know that it's not insecure either at this point?
All right. Thank you. So then we have one final presentation, which has about 10 minutes.
Thank you.
Thanks. Thanks. I didn't even think I was going to get any time. So this is some new work to improve IPsec traffic flow confidentiality. I think probably a lot of people in the room are familiar with this, but basically, this is why do we want this? Is to protect against traffic analysis, which is the act of extracting information from the size and rate of data that's sent. And the point is you can encrypt your payload, but you can still get information, from what I just said. There's actually a presentation at Usenix 2017 where they can determine which movie you're watching. They show picking which movie you're watching, even though the stream is encrypted. That's one example. So the current available option, there is an option available. It's mentioned in the RFC for ESP, and that is to pad out ESP. This has it can carry 0 or 1 IP packets. You can also have a all pad packet, right? Because you want to be sending things at a fixed rate to hide the rate. This has suboptimal performance. It increases latency and it has a very low bandwidth. So our proposed solution is fairly simple. It's to continue to use IPsec ESP, but we have we use a new payload, and inside the payload, we fragment and aggregate the IP stream. This creates minimal latency and gives us a constant high bandwidth. So we have a graph here showing these results. So the top 3 constant lines are the new solution, IPTFS. The numbers are the MTU. So that's a 9,000, 1,500, and 576. And you can see that we have in the middle, you have just pure Ethernet. So that's not a fixed size. And ESP, pure ESP, that's also not a fixed size. So there's no TFC going on there. There's no confidentiality. And then the bottom represents the currently available option, right? So it's very suboptimal for bandwidth utilization. Let's see, what time do I got? Okay. So that's sort of the sales slide. Since I have 30 slides, I'm never going to present all those. So I'm going to skip through some. The key design points, we use a fixed size encapsulating packets. We send them at a constant rate. The unidirectional thing is more about, the idea was that you could do TFS in one direction. You didn't have to do it in both. We had that as a goal in the design. So, right, I already covered that. Just talked about that. You could either set the MTU size, the fixed size, or you could use path MTU discovery. Right. So there's 2 modes. Okay, so there's 2 modes that you can run in. You can run in a congestion control mode or non-congestion control mode. The non-congestion control mode would be if you own the whole network, right? The congestion control mode is there for when you're sending through the internet and you need to be friendly to TCP. The particular thing, this actually came up on the list a little bit, and we're going to redo the way that the congestion control info is sent, because I guess I had violated a little bit the IKE spec. We also aren't married to any particular solution here. So we just need to get the drop reports back to the sender. So this is just a starting point. Right, so the non-congestion control mode is obvious. But we also allow for sending the congestion information in case you want to implement something like circuit breakers. So we'll skip that. So the basic, good, still time. So this is just some, basic packet formats. Our header is basically in more solid lines there. So you have the ESP header followed by a block offset, and that allows us to pack IP packets together. What that looks like is each data block looks, we basically reuse the first nibble. So we're not using any bytes to actually specify the data block header. We just look into that first 4 bits. So IPv4, it'll be 4, v6 will be 6, and padding would be 0. So the congestion control info will be sent on an interval, but again, I don't really want to talk about how we're going to send it since it's sort of in flux right now. This is just the introduction of this work, right? We imagine discussions on the list and coming to the best sort of solution for how to send this information. I also, it was brought up that we could do. I think Valerie, you said, why don't send it in band? And I was like, well, it's unidirectional. If we can, in fact, do, if we had just pure IP ESP coming back, through the paired SA, if we could do a next header to attach it there, that might be a solution too. That somebody mentioned to me actually. Anyway, so this is stuff we could do on the list since I don't have tons of time. The data right now, this actually is also in flux. I talked to David Black from TSV, and he sort of gave us some hints on where we should look. I basically was leaving congestion control algorithm up to the implementer, but we need to give a little bit more guidance. And so he pointed us at DCCP, which is Data Control Congestion Protocol. I don't know if that's what it stands for, but that's part of what it does for datagrams. And there are some profiles that we can look to that basically pair well with the solution. So we just need to make sure that we're sending the correct data though. And we need to make sure, so basically that turns into loss rate and round trip time. So we just need to make sure that the information that we're sending back to the sender contains enough to calculate those things. So this is just some basic comparisons. This is an overhead comparison in octets. You can see the current solution. The far left side is the, wish I had some water, is the input packet size, payload size, and the top shows the MTU of the encapsulation, and then the data inside the graph shows you the sort of the overhead, the wasted bytes. So you can see it's quite large. And if we go to the next one, this is the same numbers by percent. So you can see that for the TFS solution, it's a fixed percent and it's very small. Obviously, there's some outliers there for the currently available solution. 22,000% is horrible. They're not all that bad, but they're all pretty bad. This is bandwidth utilization over Ethernet. Again, you see that you get constant bandwidth utilization with the TFS solution, and the common MTU there. Oh, thank you so much. The common MTU of 1500 is quite good, 94.9% utilization. You can see if you look over to the left, even Ethernet, right? That no IPsec, right? For the small packet payload sizes, we're better, right? Because we have less overhead because we can pack a bunch of small IP packets into one over encapsulating header. The other thing to look at is latency. So this shows the latency. They seem very similar between the current available and the TFS, but the difference is that this represents the maximum latency for IPTFS, whereas it sort of represents the minimum latency for ESP. You can go a lot deeper into this, right? Because if you start looking at queues, you can imagine if you're padding 40 byte TCP packets into 1500 byte ESP, right? And then you have 10 of those in a queue, right? That's a huge amount of latency you're adding to that last 40 byte packet. So there's some related work that's going on in the IEEE with regards to this. They just met recently, and it looked really promising. There's progress on this, and it's anticipated in upcoming meetings as well. And I also wrote some code that's available at that link now. This is just proof of concept code. It's not actually an ESP because that's hard to sort of whip together quickly. So I used UDP. But basically what this is proving is the framing, the packing and the fragmenting and aggregating of the payload packets, as well as being able to adjust to congestion. So it does actually simulate congestion and drops and, shows that it can adjust to that. Using the information that we have in the draft that we plan to update as well. There's 2 implementations, Python and C. I'm out of time, but I think I sort of covered the open issues in band.
Very respectful for this plus. I think it's an interesting proposal, but I have a problem with it. And it doesn't relate with IQ2. It's related to ESP. So as far as I understand, you fragment IP packets into blocks of arbitrary size and put them, pack them into ESP. So on the receiving side, you need to reassemble. And in case of packet loss, packet reordering, it will complicate ESP implementation because you need to have reassemblers that must be timed out. And in the current proposal, I don't even understand how you don't have a label.
The
It's just blocks.
sequence number from ESP is how we order it.
Well, sequence number from ESP, well, in case packet get lost, so for example, so you
drop up until you get to the next.
But anyway, it complicates. So I'd rather to sacrifice some performance to simplicity. So I'd rather to put only whole IP packets into ESP, but make it available to combine several.
I see what you're saying.
So it will. That's why we don't need reassembly on the receiving side. It will simplify and.
Yeah, it will affect the nice numbers, but yeah. So why don't we discuss that more on the list?
Paul, quick, because we're over time.
Yeah, okay, Paul. So I think that this draft seems to be doing 2 things. One of them is sort of providing privacy, and the other one is sort of compressing various small packets into bigger packets and saving latency. I think those are 2 very different goals. And for the first goal, the privacy, the RFC you quote about ESP allows you to not only do padding, but also send dummy packets. So from a privacy point of view, the existing RFC already covers everything you would want to make a stream look like, a similar monotone stream. So I think maybe clarify a bit why you want to do these other things that are like additionally complicated, because I think that's where the real work in this draft really is.
Sure. Yeah. I mean, the 22,000% overhead was one of the reasons, right? But go ahead, Lou, if you have a comment.
Lou Berger. My understanding is from implementations that have actually tried to do the existing RFC, it basically isn't deployable. That it translates into what looks like a variable loss link because of the expansion. If you think about a normal packet distribution, well, it used to be bimodal, really trimodal. Most of the bandwidth is in big packets, but most of the packets are little small ones. And we end up just destroying the available bandwidth because of the expansion. So, well, he's not listening. But the existing RFC, it doesn't work. That's the problem that's trying to be addressed here.
All right, so thanks. We'll take the rest of the list. And that concludes IPSECME for this week. Thank you. If you need to sign the blue sheets, please come up to the table. Yeah, you're welcome. Yeah, sorry we couldn't provide more time.
I was actually surprised that we didn't go more over than that.
Yeah, you're welcome. Thank you.
That's why I did give you a warning saying.
I was just through 2 minutes ago when they do some free slides and things. Go to the list or whatever.
That was great.
Here's the teaser.